Welcome to your lesson today on lesson 2.6 on drawing scatter plots and best fitting lines. I want you to recognize that drawing scatter plots and best fitting lines is going to be based on real life data. Alright, a lot of times the information that we give you on the problems is pretty unrealistic. Find the slope between these 2 points and make a line of those two based on those 2 points. And so what we do a lot in math is we try to come up with examples that are real life, but sometimes they're really not. Really, I want you to recognize that scatter plots and best fitting lines is exactly using real life data to make equations of lines. And so we're going to kind of continue to use what we've talked about in lesson 2.4 about graphing lines and writing equations of lines. And so if you haven't watched that video yet, I encourage you to go back and do that one. Because it's going to make a lot more sense. This video will make a lot more sense based on that. All right. So first of all, a scatter plot is a set of data xy, and again, it's the graph of a set of data xy. So basically, it's just a whole bunch of points that we get some x's and y's, and again, x and y are different values based on what we're given for our particular problem. All right. A positive correlation is a relationship between paired data where y increases as x increases. So it talks about paired data, but basically as x increases, y increases. So as to say, as we increase the value of x, the value of y goes with it, and so that's going to be a positive correlation. A negative correlation says as x increases, y decreases. All right? And so a positive correlation might be, we may find a positive correlation between, study time and test scores. Okay, as they increase the study time, students tend to do better on their tests. A possibility of a negative correlation might be, say, time on Facebook and test scores. So as I increase the amount of time on Facebook, my test scores tend to decrease. So I get data that would look something like this. Maybe not true for everybody, but generally speaking, those would be examples of positive and negative correlations, at least what I would anticipate them to be. All right, correlation coefficient is some number r. So first of all, we use the variable r, much like we use m for slope and b for y-intercept. R is the correlation coefficient, and that number is between -1 and 1. All right. The correlation coefficient, if it's negative, it means that it has a negative correlation. And as you can bet, if it's positive, that means that it has a positive correlation. All right. And so two key ingredients to that is that negative correlation is a negative correlation coefficient. Positive correlation is a positive correlation coefficient. And then r being exactly equal to 1 says that it's exactly a straight line. And it's exactly a straight line with a positive slope. If r is -1, that says it's exactly a straight line with a negative slope. So there's an awful lot to squeeze in that box, but kind of fit it in wherever you can. Negative correlation coefficient says it's exactly a straight line with a negative slope. Positive correlation with r equal 1 says it's exactly a straight line with a positive slope. Now anything in between basically just says that the correlation coefficient is not quite as strong. So if the data is exactly a straight line, it'll be a correlation coefficient of 1. But if it has a positive correlation much like this, okay, now my data isn't exactly a straight line, so the correlation coefficient might be less than 1, but it's still going to be positive because it's a positive correlation. So we'll get into an example of that here shortly. Now, a best fitting line is, I'm going to say, now we got to be careful about this. I'm going to say a best fitting line for my data. Now, the reason I say a best fitting line for my data is because every student is going to draw a different line of best fit, provided every student could choose different points. So depending on which 2 points you pick when you draw your line, which this will make more sense when we do an example, depending on which points you pick, you may end up coming up with a different line of best fit. And everybody can have different lines of best fit, provided they're all about the same. And again, that's what happens when you use real-life data, is you don't get all exactly the same results. All right, so let's talk about estimating correlation coefficients. As I draw a line of best fit here, I'm going to draw a line of best fit that has, you know, something that fits my data pretty closely, and we'll talk more about the way to do that in just a few minutes. We're going to draw our best fit line in here, and as I draw that best fit line in here, we can see that that data has a very strong negative correlation. Okay, it's a very strong negative correlation because as x increases, the values of y decrease, right? So my points generally are more working downward. So again, the slope of this line is negative, and so it has a strong negative correlation. Our best estimate given this is that r is pretty close to -1. Again, I'm going to change this to approximately -1 so that you can see that it shouldn't be exactly -1 because the data is not exactly a straight line. But the closer that data is to a straight line, the closer that number gets to 1. In this case, since it's a negative correlation, it gets close to -1. All right. In example B, the data tends to follow a positive correlation, but it's not quite as strong. So we're going to say this is a weak positive correlation. And so R is somewhere between 0 and 1, but obviously it's not too close to either one of them. I would say that this is a correlation coefficient of probably closer to 0.5, and I bet almost inevitably when you did this you'd get something more like 0.7 or 0.8, but we're just estimating the correlation coefficient for right now. Again, it's positive because the data is increasing. As x increases, so does y, and so it's a positive correlation, but since the data doesn't fit exactly on a straight line, we know that that number is probably somewhere closer to the 0.5 variety. All right? Now, again, tomorrow when you guys come to class, bring your graphing calculators, and I'm going to show you a much better way to do this. But you do need to know how to do this manually for those students that don't have access to a graphing calculator. All right, and so when I approximate a best fitting line, the first thing I need is a scatter plot. Okay, I want to draw a scatter plot of the data. Then I want to sketch the line that appears to follow most closely to the trend given by the data points. Again, it's going to appear to, because it really depends on which 2 points that you choose to go to make your equation of your line. You can choose points, and I'll get to that part here, so I'll hold on to that thought. Anyway, there should be about the same number of points above as there are below. Now, this is about the least scientific thing you could possibly do for drawing a line of best fit. We plot all the points, and then we just kind of say, well, it's about like that. And I get about the same number of points above as I do below, and so that's our best fitting line. And that's the best that we can do for right now. All right, as I said before, we'll come up with a better way to do this on our graphing calculator. All right, so now we're going to choose 2 points. Whoops. Choose 2 points that are right on the line, and we're going to estimate the coordinates of those points. Sometimes you might choose, and this is that point that I was going to get back to, sometimes you might choose given data points, or you might choose points that we get from the graph. And I'll give you an example of each when we do our next example, okay? Sometimes you can get those points from the graph, sometimes you can do them with the given points. All right, and then finally we're going to write an equation of a line that passes through those 2 points, and that will be our equation of our line of best fit. All right, so let's go ahead and approximate a line of best fit, and I want you guys to pay special attention to a very key word here, and that is approximating. Okay, we're going to be approximating a line of best fit here. All right, not every student is going to get the exact same answer for this, and the reason for that is not every student will choose the same 2 points in step number 3. But let's go ahead and draw a scatter plot first. And so we have 1, 722, which is roughly there. You have 2, 623, which is roughly, 763, which is in there. At the third game, we have about 772, which should be slightly higher than the last data point, but certainly not as high as 800. On the fourth game, we have about 826. On the fifth game, slight drop in attendance, back down to 815, so slightly above 800, but not quite to 850. On the sixth game, we're just over 850, and on the last game, we're darn close to 900. All right? And so we're going to make a line of best fit, and I'm going to see if I can make a line of best fit that fits our data pretty closely here. All right? All right, now, I just drew a line of best fit, and as I'm looking at my data, I can see that I have, as I'm counting my points, I have 1, 2, 3 points above. I have 1, 2, 3 points below. And according to this data, I only have 1 point that fits right on, and that 1 point was an approximate anyway. All right? Okay, now, the rest of these notes were contingent on something, and I want to make sure that I share this with you guys. When they draw the line of best fit with the computer, because they have the ability to do that, when they drew the line of best fit, they came up with 2 points that crossed right through my line. And so what I want to do now is I want to go ahead and clear this thing off of here, at least part of this, all right? And I want you to recognize that when the book did this, they chose the point 722, 1722, and because their line that they drew went exactly through 2750, all right, they chose these 2 points as 1722 and 2750. Now again, to be consistent with what they're doing so the boxes will make sense from here on out, I'm going to go ahead and use their information. Again, assume that the rest of the data is still plotted out here somewhere. But that's the 2 points that they chose, so those are the 2 points that I'm going to go with. All right? All right, so write an equation of the line. The equation of the line passes through the 2 points and has a slope of the following. Well, to calculate slope, we do y2 minus y1, so it's 750 minus 722 over x2 minus x1, which is 2, take away 1. This comes out to 28 over 1, or simply 28. And so the slope of that line is 28. All right, so we get a slope of 28. Now going back to lesson 2.4 on writing equations of lines, remember we talked about y equals mx plus b, and we also talked about y minus y1 equals m times x minus x1. We can use point slope form or slope intercept form. In the book they tend to use point slope form a lot more. I tend to use slope intercept form, but I'll go ahead and follow through with point slope form. If you like slope intercept, go ahead and do it that way instead. So now we're just going to choose one of the 2 points. I'm just going to choose the 1722. And so it's y minus the y value equals m, which is our slope, that came out to 28, times x minus the x value of 1. Now, they kind of skip some steps in here, so I'm going to go ahead and do it over there. Distribute the 28, and so I get y minus 722 is equal to 28x minus 28. And then I'm going to add 722 to both sides. And so I get y equals 28x plus 694. And so the equation of the best fitting line, sorry, it's right down here, you can't see it, but it's right down in this next line here, is y equals 28x plus 694. Now, if I were to choose 2 different points from the beginning of this, I might get a slope of 27.5. I might get a slope of 30. I might get a slope of 26. I might get something different for a slope based on what 2 points that I chose. And so because of that, I might come up with a different y-intercept. And that's okay. Again, I want to go back to what we talked about before. You're approximating a line of best fit. So as long as your slope is something close to 28, you'll be fine. As long as your y-intercept is close to 700 or 694, you'll be fine. Okay, if you came up with a negative slope here, chances are you probably did something wrong. All right, if you came up with a y-intercept of, say, 20, well, that's obviously way off of 700, and so that's where we were going to kind of take a look at finding some errors there. All right, so using a line of best fit, now once we have our equation, we can then use that equation to make predictions. It says use the equation of the line of best fit to predict the number of people that will attend the 10th football game. So because you're predicting the 10th football game, we're going to plug in 10 for x. And so I get y equals 28 times 10 plus 694. From there, 28 times 10 is 280 plus 694. And 280 plus 694, that comes out to be 974. And so we can approximate just short of 1,000 people to attend the 10th football game. All right. Now, again, if you came up with an equation that was slightly different than this, maybe you got y equals 27.5x plus, say, 700. All right. We'd plug 10 into here, and we would probably get something very, very close to that. In this case, we would end up getting 975 people, as opposed to the original estimate of 974. Pretty close, but they're estimates. All right. So I want you to try the next 3 examples. The first 2 are pretty straightforward. Just examine the correlation coefficients of those, and then go ahead and make a scatter plot, and let's see if we can't see how this goes. You may get a different answer than I do on number 3, and that's okay. And we'll talk about how close that should be in just a moment. But go ahead and try 1, 2, and 3 as examples. All right, drawing a line of best fit. We're going to kind of draw a line that fits maybe right in here. And remember, we said that our goal for drawing the line of best fit is to have the same number of points above as below. All right, obviously maximizing the number of points on the graph would be ideal. So in this case, we have 2 points that are below, we have 2 points that are above, and as you can see from the picture then, you also have 2 points that are right on the line there and there. All right, so that's a pretty good line of best fit. The bottom line is that the data pretty closely follows a straight line. This is a very strong positive correlation, right? Because we know it's positive because as x increases, so does y. Or another way we can say it is the slope of this line is positive, right? So since the slope of that line is positive, it's a very strong positive correlation. And so we would expect the correlation coefficient to be somewhere close to 1. And again, I'm going to use approximately equal to 1 because I don't want to say exactly equal to 1. All right, what about the next example? You can't really draw a good line that hits most of the points because I can do something like this, but I still have these extreme outliers here and here. And since our data points, it looks like there's only about 7 points there. All right, that's no good. What about if we went like this? Well, that way hits 3 points, but I still have 2 that way and 2 that way. So because of that, this one we would say has relatively no correlation. Okay, relatively no correlation for this one, and so the correlation coefficient is probably pretty close to 0, right? Because the data doesn't look like it follows a line at all. Alrighty, here comes the more difficult example. Let's finish this thing up. Let's finish this thing up by taking a look at actually making a scatter plot and going through the whole process of creating a line of best fit. So first of all, the table gives the average class score, Y, on each chapter test for the first 6 chapters, X of the textbook. So the chapter is your X. 1, 2, 3, 4, 5, 6. Each of the 6 chapters are your X's, and your Y's are the resulting class average. So for the first test score, we had an average of about an 84. The second one down just a little bit to an 83. The third one we're up to an 86. The fourth one we're up to about an 88. And the last test average is pretty close to 90. All right? So that data does not follow exactly a straight line, but what we can do with that data is we can draw a line of best fit that best approximates that data. All right? Now, depending on which 2 points you chose, you could make your line look something like this. All right? That gives you 2 above and 1 below. Okay? Your data line might look more like this, where now you still have 2 right on, 2 below, and 1 above. And so I'm just going to go with that line of best fit because that's pretty close to what I'm going to use. All right? And so I'm going to label these 2 points as the points that I'm using, here and here. And so my 2 points that I'm using are 488 and 590. All right. And so when I go to calculate, first of all, then to write an equation for that, the first thing I need is I need a slope. So m equals y2 minus y1 over x2 minus x1. So we get 2 over 1, so I get a slope of approximately 2. All right? Now, once I have my slope of 2, the book likes to use point slope form. I like to use slope intercept. I like to say y equals mx plus b and plug in an x, a y, and an m. It doesn't matter which of the 2 points that I pick. I'm going to pick this one just because it seems to be easiest. And so 90 is equal to 2 times x plus b. And 2 times 5 is 10, so I'm going to subtract 10 from both sides. I get b equals 80. And so the equation of the line of best fit for this is y equals 2x plus 80. Now, what if you pick different points? What if you would have picked 2 entirely different points? Maybe you picked this point and this point. You would have come up with a different slope. And because you get a different slope, you'll get a different y-intercept. But generally speaking, as long as the slope is something approximately 2 and the y-intercept is something approximately 80, you should be fine here. All right? If you got a slope of something negative, then we obviously made a mistake there somewhere in our calculation, and obviously the y-intercept is going to be incorrect as well. All right. So again, this is all approximating. Tomorrow I'll teach you how to use your graphing calculator to plug in that data, and once you've plugged in the data, then you can get a line of best fit from that.